continuing our discussion of hydraulic head, H, and its two components, Z, elevation head, and psi, pressure head, I want to make a point, and that is that individually, neither of these alone determine the hydraulic head. It's together, their sum is what dictates the hydraulic head. So that's important enough that it bears writing out. So neither elevation nor pressure head are individually adequate. But together, they describe the potential. And from hydraulic head, we can get to potential. So what is this relationship between potential and hydraulic head? Well, the potential is the mechanical energy per unit mass. So it's normalized to an amount of water. And in general, below ground, water is moving fairly slowly. It's seeping through little pores such that the kinetic component is negligible. It's very, very small. And so it's really just this pressure term and this elevation term, or you can kind of think of this as the height above a particular datum that determine the head. And the relationship between potential, which I'm going to draw with this symbol, on Earth's surface, is that it's the hydraulic head times g, where g is the acceleration due to Earth's gravity. Okay, so a key concept when we think about how water flows in relation to head is that water flows down energy gradients. So water flows down energy gradients. Just like if you're skiing, you are going to go from high elevation down to low elevation. Water wants to flow down an energy gradient, but it's not just elevation, it's also this pressure term that determines the energy gradient. And what does this word gradient mean? It means the change in a scalar quantity, like potential, over a particular distance or length scale. And this concept in hydrology, Darcy's law that says water's flowing down energy gradients, actually has a lot of analogies in other fields of physics and chemistry. So analogous processes we know heat conduction, for example. According to Fourier's law, heat flows down a gradient in temperature. It flows from something that's hot to something that's cold. Down temperature gradients. We know electricity and Ohm's law, for example. We know that electric current flows from areas of high voltage to low voltage in a linearly related, linearly proportional way, just like Darcy's law. And finally, in chemistry, we know that the diffusion of molecules, according to Fick's law, says that in general, molecules will flow down a gradient in concentration from areas where molecules are tightly packed to areas where their concentration is smaller. These are all mathematically analogous to the flow of water in response to a hydraulic head gradient according to Darcy's law.